Hello, welcome back to Academy for Tech. So today we'll be discussing about RoboDK, it's a simulation software, and we'll be working on it. And we'll try to simulate any industrial robot or the robot which you model. So in the RoboDK we have option where you can create a 3D model of your own robot and then do the simulation. So let's have a look at this RoboDK. First of all, we have to download the software. So you can go to Google and type for RoboDK. So here you will get a you can see here the RoboDK simulation for industrial robot and offline programming. So here it is like in order to be an industrial robot, can be you can also customize your own robot like 6-axis, 7-axis. According to your willingness, you can develop your own simulation. So actually recently gone to the software and I was able here you can get a lot of documentation and instruction to use RoboDK. So as of now I'll try to give you a basic idea how to use your own software. Keyboard. Okay, first of all you download the software. So here you can see this all the platform it support. In Windows you have 64 and 32, Mac OS, Ubuntu, Raspberry Pi. Even you can work with the Raspberry Pi, and you can also visualize and work with Android or iPhone. So you can click which platform you are using. So it is irrelevant of platform, you can work on any of this platform. So people who have difficulty in using a laptop, you can work on Android or iPhone. So let's go with Windows 64-bit. Okay, it's downloading. So let's go on. So I'm opening RoboDK. And so talking about RoboDK, so in the RoboDK, okay, it's going on. Okay, we'll get around 30 days trial version where you can use and utilize for this 13-day trial version. So actually for studying the RoboDK it may take not more than 1 day or 2 day. So you can follow my instructions. Here in the RoboDK, so you have multiple icons here. So here you can go for open online library if you're going for the robot which are available in the market. And in case if you have your own robot to be simulated, I'll just give you the instruction for that in the coming videos. So yeah, I hope my simulation will be helpful for you to also to simulate your own robot. Here there is a big library. Here you can see you can filter different robot with brand. So you can see there are multiple robots. So you can not only working on a single robot, you can work on multiple robots, and you can also connect to the robot IO device. So we also have this specification. So let's say I'm taking a robot, let's say KUKA robot. So actually yeah, so I'm going to KUKA robot. So I have filtered using the brand, and next I can go for the type. So how much degree of freedom you need, like 5 degrees, 6 degree and 7 degree. You can also see the number of robot available for the multiple degree of freedom. So and also we have multiple axis and multiple payload. Usually we will go for the payload because we had to find account of application. Let's say we have an application around 20 kg, around 50 kg. Let's take this. So you can see multiple robots here. So let's say I'm working on 30 kg payload. So I'm downloading this robot. Yeah. So I have my robot in my environment. So next thing is that you need to have a gripper. Okay, so if you press Alt button, you can see the icon changes, and we can control the robot motion by just clicking on Alt button. So next thing you had to know that what environment you are working your robot, what environment you are planning to work with your robot. You can create your own environment by using your own 3D softwares like SolidWorks, and you can also create your own gripper. So in my case I have developed a gripper so myself using SolidWorks, and I'll just import to this RoboDK, and I'll try to show you how we can use a pick and place process using RoboDK. So I'm taking my SolidWorks. So actually SolidWorks is also a simple software where you can use the for different designing, so multiple designing. So you can create for this particular application, you can create an IGS file, so the robot can able to open directly, and you will have an add some plugin with the SolidWorks where you can directly open through the SolidWorks directly. And talking about RoboDK further, so there are different instructions here, you can give one by one instruction, and you can work with Python coding, and you can also do programming. So these sequences are very easy and you can follow very easily, and you can also export the your simulation as a PDF by clicking this button. So here you have the multiple options like HTML, PDF, so you can save it. And these are the target where we can ask the robot to follow. For example, I have created one single target, and I'm moving my robot to particular motion, and again creating another target. So if I need to go to initial target, I can just press this and next go into second target. So this is actually a PTP coding. In normal robot like KUKA industrial robot, we usually use point-to-point simulation or point-to-point motion. So you can follow the same in RoboDK. So we have a software for doing designing, and I'll just go through the few simple steps of design. So I need to create my own object which I had to pick and place. So let's see how it's work. So first of all, we go with the file and create a new file. So here you can see a couple of options like part, assembly, or drawing. So we can go with the part if we're using a single module or single part, and if you have multiple part and you have to assemble, you can use assembly. So let's go with the part. So if you're new to the SolidWorks, I just need to make sure you know the basics, what is front plane, top plane, and right plane. So front plane is actually a plane where you can see the front view of an object, and when talking about top plane, the top plane where you can see the top view of the objects. So if you create, I'll just show you how we create an object. So currently I'm taking a top plane. So if you need to create some solid a part, we have to go with sketch. So now we have a top plane. So what I'm currently designing is, I'm designing a part which a simple part which the robot can take. So let's design a small rectangle or some specific part looking like rectangle. So here I have just created a rectangle, and I can use the smart dimension to check what is the dimension of my the rectangle. So this is 37.4 mm. So currently I have chosen mmgs millimeter gap. Okay, 50 centimeters. So 50 centimeters. So I had to create I can give here centimeter also. So it will be converted to mm. And again I'm creating around 50 centimeter here. Okay, let's go with 80 centimeter, 80 centimeter. So we can create a rectangle. So why created 500 to 800 means I just need to make sure you understand how I use a gripper. So let's exclude it. In the exclude option, we can give the height, how much height you need to give to this particular rectangle. So I can give 10 mm. So let's say I'm giving around 10 centimeter. So if I'm giving 10 centimeter, 10 centimeter, I can mention the unit, so it'll automatically convert to the mm. You can use any unit, but it'll be converted to mm because I'm using the mmgs as my standard. So I have converted. I can just give some premium look by giving some fillet. So I'm just giving you few fillets to my 3D object. When I press the center button of my mouse, I can able to rotate the body. So I'm just giving a fillet. Let's say I give around 10 mm. Yeah. So my part become like little it look little smart. So okay. So if you press a space button, you have an option to change different views. As I told earlier, this is front view, top view, side view, like different views you can have. Like when it, and one more thing, like in the RoboDK, so you had to make sure all the dimensions, everything is correct. And when we are like taking it to the RoboDK, so currently I'm saving it to my desktop, and I'm taking this as a part 1. And I'm saving as an IGS file, so I can open them in my RoboDK. And next thing is that I need to create an environment for the robot to work. So I'm just creating a cell. So you can also get a cell in the RoboDK itself. They will provide a cell. So instead of that, I just need to like teach you how we can create our own cell. So I'm currently removing my filter, and I'm going for the other. I think I need to actually I need to remove my filters. Yeah. So here I can go to other. Well, there's a lot of options are there, like objects. You can see different like model frame 3.5 mm. So I can choose this one, and let's say I can also use this like thing like I can add to the robot. So I'll just show you how we can reorient it, and I'll just create a cell for the robot. Okay, I'm just doing with my own cell instead of using the options available in the RoboDK. So I'm creating a part. Okay, for my robot, I'm just considering like I'm giving a cell of 5 into 5 meter. 5 into 7 meter. Okay, as per. So I'm again taking it to top view. So usually when we are designing it will be very useful if you're creating this center point at the center. For example, okay, this is if I keep a rectangle with a center point as a axis, I can easily export to the RoboDK. So my cell will be like 5 meter into let's say 7 meter. Okay, here I'm using 5 meter. Okay, here it can be 7 meter. So there are a lot of options in like SolidWorks where you can use any unit and it will be automatically converted. And I'm just excluding it like around 2 centimeter. So okay, so we have created like rectangular space and like 5 meter and to 7 meter, and I'm just giving a like okay. Here again I can go for the sketch option, and in the sketch option I'm just creating a like something similar to a cell. I'm just creating a so I can go for offset. Okay, I can create a offset of 1 centimeter. So I can create a wall of 1 centimeter, you can see here, and I'm just going for the so with a 10 centimeter offset I can give a like 1 centimeter like width wall. So I'm also creating a like entrance for my robot so it can work like smoothly like in my cell. You can custom design your cell as per your requirement. Actually I'm just creating a rough sketch so you can have a like better understanding how the things work in the how we can export and work in the like RoboDK. And you can use this trim tool, so you can trim the unwanted portions. So I have trimmed and I have created a path for the wall, and I'm going to extrude it. So let's say I'm extruding to around 2 meter. So okay, I extruded it. So we have created a small environment for the robot to work, and this is a rough environment. You can design as per your. You can also use different transparent wall or what type of environment, working environment you need. So I'm just saving this as a IGS file, so I can directly import to the RoboDK. Okay. Okay, I have completed my work with the SolidWorks, and I'm just closing it, so we can focus on RoboDK. Here here you can see it is being merged. The robot and the object is merged, and you can use this. You can put this inside the robot. Yeah, and this will be acting as, you can see this acting as a tool. So you should create a reference point so that you can able to handle everything easily. Okay, so I need to move the object so that it look like it's based on the base. So as you know, it's 750 mm, so let's move at 750 mm and check whether it's getting the output. So okay, so we here we have three options, X. This will be along X direction, axis along X direction, and Y direction, Z direction. So let's take it 750 along Z direction. So this is a positive, so we have to go with the negative. So now is placed in the robot base, and here you can see, and these are used you can rotate. You can use your center point of your mouse, and you can readjust in case you need to adjust any fraction. So I'm going back to 0. Okay, as I told, okay, I forgot to explain this. In this part we can use X, Y, and Z. These are the direction where you can move, and these are the rotary motion. X, you can rotate around rotation around X. Similarly, a rotation of Y and rotation on Z. So we have the robot place, and I'll try to import my SolidWorks file. So I'm opening my SolidWorks file. So since I created a 2GS file, okay, I have a part 1 and a part 2. Okay, you can see there is a dimension mismatch here. So you can readjust it by changing different angle, as I told, an X. I can see this is along X direction, Y direction. So let's give a 90-degree inclination. So okay, so from the image you can see it is the robot and my working environment got merged. You can change with the help of here you can see I'm using my mouse to move and different places, so I can use center point of mouse and rotate it. So I'm creating around 90 degree inclination. Yeah, similarly I need to give the base is laid down, so I need to move it downward. So I'm giving minus 750. So currently the robot is placed perfectly. Okay, now we need to, yeah, where is my part 2? Okay, where's my part 1? So my part 1 was my object, so I'm taking my part 1 out. So let's see where is my part 1. So I can see my object here. So this is the object which I'm planning to pick in place, and I'll just import and gripper. So I'll open my program. Okay. Okay, I'm taking my gripper in. So where's my gripper? So actually I created a gripper using SolidWorks. So it's a vacuum gripper, and I'm importing to the SolidWorks to the RoboDK. And so let's attach to the robot end effector. It is taking some couple of time because the part is little bulky, so I can just move to the robot, so it will be acting as a gripper. Okay, I think I have, I got a wrong image. Okay, I just need to confirm the gripper. Yeah. I'm opening a gripper. So let's check with the gripper. My small gripper. Okay, so I have my gripper here and exporting. Okay, so I'm taking my gripper, I'm importing to the RoboDK. So actually I have developed my own gripper using SolidWorks, and you can also customize your own gripper as per your application. You can create your own working environment, and you can work with the environment using the any type of robot from Kuka, and even you can customize your own robot and you can give multiple axes. So here I have my gripper, I am moving to robot, so it'll be connected to the robot. So you can see my gripper here. You can model it by giving colors. So I think I'll go to my SolidWorks and give some colors and come back and let's check with that. So now I have an environment, I have object, I have place, and I need to put my gripper. And before putting my gripper, I'm just adding a table. So I'm just going to the here you can see one object. You can add a table, and you can also use the model available here. So here is my table. So I need to move my table to specific around 1000 meter. Let's say 2500. So I'm okay 2200, and I'm rotating. Let's check with the. So you can use the roller in the mouse to navigate through the environment. I can also rotate it any direction, 90 degree around X direction, or Y direction or Z direction. See, you can see here. So I'm just moving. I can also still use the alt option. Okay. I'm just moving it more further towards the robot. So I'm just giving 2000. Okay, you can move away from the robot also by okay, let's have a two table. I can also copy and paste the table to also provided two tables, so you can see. and I'm also giving an integration. It's already done here. I'm moving in the y direction around, let's say 1 meter. Okay, minus 1 meter. So we have a two table here. I'm just taking this table. Okay. So we have a two table place. Okay, I think it's like merged it inside the wall. So I'm just moving to more inside. Yeah, I think 2050 will be best. Okay, I think now it's look fine. So I need to move my object also. So this is my object and I'm giving 1500. Okay, and I'm giving some height, let's say 1000. Okay. So it's moved up a little bit. I just need to like change the position. Yeah, let's change it. Okay. I just need to move down a little bit further. I can change here. Okay. I can move a little bit further. Okay, I think now it's look fine. So you can use the mouse rollers to see the environment like very smoothly and see how. So my option is like I need to move this object from here to this table. So we need to simulate that, and it look this actually the environment is looking a little more fine. So this is a simple like basic model I created. You can also create and customize, and you can also give multiple colors. For example, if I'm going to give the color for this particular model, I need to press that and I need to select the object. Like first of all, I deselect everything. So yeah, here you have an option for more option, change color, select it and change any color you need. So I'm giving red color so you can it'll be noticed very easily. And I can also change the like, for example, I need to change the like surface here. I need a let's say I need some other background here, like, so I can change everything. And I can also change the faces. So for example, I need to change this face, so start the color, let's say this. So I'm able to change the face, so the like working environment look like much better. Okay, hello, yeah. So here we have created the object, and now like first of all we need to have a like gripper. So I created a gripper previously, so I'll just open my gripper here. Actually, yeah, I think this is my gripper. So I can just drag and drop into the RoboCurve, like into the RoboDK. So my gripper is loading, so I'm just waiting a couple of minutes. Like, so I hope you'll be able to understand the process of picking and placing using RoboDK with the help of industrial robot KUKA. And you can also utilize different robot, like I said previously, like mentioned, like universal robot, ABB robot, and different motorman, different robots available in the library. So you can also create your own robot and export and import to the RoboDK. I think my gripper is ready, and I'll just check with my gripper. Yeah, Okay, you can move to the robot, so it'll be attached to the robot, right? Since as I told earlier, we may have to readjust if your position orientation is not right. So I can click on the vacuum gripper here, and I can change here some values. Let's say I'm just changing to 90 degree and see what will be the output. Okay, actually I had to go for the more option. Here I had to change the values. So this is actually the TCP of the tool, like tip point of the tool. Okay, and here is the more geometry of the tool. So here you can see if it had do any changes, it will be reflected into the tool, like into my gripper. So I'm just giving some changes like 180. I can go for 270, and I can randomly change here. So I can also use my mouse pointer. And here also I can change the rotation. So orientation can be like adjust. We will check the robot position. So I think this should move. Similarly, I need to move my grip a little bit, like further from the robot. So it's look like attaching. So what I was doing was I'm just clicking any of this, like I'm readjusting the geometry by pressing here, and I'm changing the scroller, so we can able to understand exactly how we can move. And you can also see and identify by left clicking and zoom in, zoom out. So you can see there is a small orientation issue here, so we can fix it by moving it along y direction. I think it's look fine. And you can also disable and show the TCP, and you can move the TCP as per your requirement. So you can also have option to disable visible and non-visible on the tool. So I'm closing it. So now we have the robot piece, and I'm just creating a small reference point. So if you're creating a reference point, so with the respect to this reference point, we can create the motions. So this is my reference point, and I'm creating this at home position. Let's take let's move the robot. We can press on the Alt button and move manually. So I can move the robot, and you can also move the robot if you press double tap the robot. We have a bunch of options here. You can test it like X direction, Y direction, and you can also rotation. You can also test with the rotation also. So similarly you can also move different joints, like different 6 joint. So you can see how we can move the multiple joints here. Okay, these are the motions we can do with the robot to to make it accurate positioning of the one object, any objects, placing one object to another place. So okay, let's go with the frame one. So I'm creating this as my reference point, and I'm activating the reference frame. So once I activate, I can create a home position initially. Let's take this as a home actually move my robot a little bit, I need to create a home position. So you can try this when we try to design, so you can able to understand how these things work. You can also, as I told, you can also use this motions. You can readjust positions. So let's say I'm taking this as my home position, and I'm creating a target, and I can press Alt F2 and change to the home. The Alt F2 is for Windows, and if it's not working, you can try with F2. So this is my home position, and I'm moving my robot to my object. Okay, I'm just moving. I can use the Alt button. Okay, or I can just. So when you're moving, you can see a skeleton model, so it will give you a reference with like how you're moving. So I'm just more, to make it more precise, you can use these tools like X and Y and like Z. So I think we have to do rotation, Z rotation, to make it more oriented, and I can use R button. So I'm moving, and you can check it. I need to move it a little bit down. Okay. In case if you like mess up with the zooming, you can press this one and reset it. Reset the like zoom position. Okay. So I can press. Okay, I'm just adjusting to the. Okay. Okay, actually I have repositioned my like gripper to the like object, and here it's like it seems like a little more like attached to the robot. I have created target 2 and I'm just moving to the like home position. Okay, and just moving to the target 2, seeing like everything is aligned. So what is my next process is that I need to make a program and I need to connect my like object to the gripper, and I'm starting my program with a reference to the frame 2. So you can press on the program frame 2 and okay, so frame 2 program. You can use control to press on the multiple like parameters like frame 2 program, and the home position it will be my initial position, and I had to go here and I'm putting okay, when I giving a key like move J, I have like assigned the program to move to the initial stage. And next I can go to the target 2 where I'm positioning my object. I can try with the move J, move L. So it's move L, and now I need to attach my object to the robot gripper. So you can go to the add instruction, simulate event instruction, and attach the object. And in case if it is not attached, you can try with like you can manually like connect the object. Again, here is an object, couple of objects like position list. So when we are attaching, you can see a couple of options here, like if in the default will be attaching. And next I'm creating another move to the home position. So I'm pressing on the program home position and move L. So let's run the program and see how it works. So the object is not attached, so I need to like edit the instruction here. So you can go for the instruction simulation. Here you can manually adjust it. You can hear TPC here, the like object position any object position listed or surface. Okay, I'm just going to the surface, and you can see here bunch of like instructions, and we have to know which is a part 1 or part 2. So part 1 will be my like initial object, so I'm pressing the part 1, and now I'm running my program to verify that it's working. Yeah, so my object is like I'm able to like pick my object by using the command. Okay, so I need to like pick and place to the like nest table. So I need to create a couple of targets. So I'm just moving my robot. Like I can press the Alt button and I can move my robot to, or you can use these options to move your robot. So yeah. One more thing you have to know that you have to check whether the robot can move to this particular location, or if the coordinate is ready, or if your table is more far away from the robot, like you have to check with that like initially. So I'm creating a couple of targets here. Target point, I'm giving you target 1, target 3. So let's move from target 2 to 3. Okay, you can see the robot motion. And I'm just I need to drop the object. Okay, I need to like make sure I keep okay, I need to delete the target 3 because if in case I'm using the target 3, there's a chance that it can hit in the table. So I'm deleting my target 3 and recreating. So you had to like make sure you're giving a like little more like accurate target. And again, I need to move my robot here. So here you can see. So yeah, when you create I can use the Alt button. So yeah, move a little bit. I can use this translation motion like X or Y, like where I need to move. So I'm using. Okay, I need to move down and need to. So this is like a trial and error method. So you can like it will take some couple of time we reorient. So I have readjusted the like position and I'm able to keep like above the table. And here you can see there's a slight problem here. You can adjust it with the options here. So I think it's around okay around y direction, yeah. So you can readjust. You can observe like clearly. So you can like move your mouse. You can move the like frame with the help of mouse. You can see there's a slight problem here. I need to readjust it slightly. Hope. So once you are familiar with this particular software, you can able to make it like more accurate. Okay. So I need to be okay. I think now I'm able to keep in place. So I'm creating a target 4. So we have target 3 and target 4. And okay, now I need to like in the program I can set here program 1. So let's run the program and test where currently my robot is placed. Yeah, okay. So I pick my like object. I need to go to target 3 and next target 4 and the place object. So I'm pressing my program 1 target 3 and move L. Similarly program 4 target 4 program 1 and again move L. So yeah, next I need to put my object like in the table, right? So I need to add instruction to keep my object in the table. So before that you had to save your file, like actually forward to save it. So saving the session is very important in case if you go like problem like if you unsave your project, in case you go into like your code is closed or like you may not be able to like define it. So I'm creating an instruction to keep my object in place. So here actually we are working with respect. Here you can see an object called detach object. So I need to detach the object with a reference to my frame 2. So the frame 2 is my active frame So I'm clicking OK. Next I need to go to home position, so again I'm pressing on the program home position. Yeah, I think it's working cool. Yeah, it's place and go to the home position. So we have completed the process of picking and placing the robot. I'm concluding this today's session, and I hope you have a better understanding about RoboDK. And for working with RoboDK, you can choose your own robot using the online libraries, and from the online libraries you can add the robot and a lot of other tools. And for the gripper mechanism, you can design your own gripper. So for the gripper you can design your own gripper and you can attach in the RoboDK. And there is a mechanism called like so there's a method called like frame, and with the help of frame you can like connect individual object through the frame, so you can have a overall control about the objects available in the RoboDK. And you can do simulation, you can do programming a PTP like point by point. So as you followed by like my structural view, how I have utilized the programming section like move J to move L, and how I attached my like object to the robotic gripper, and how I have detached it. So I can just show you the process. Yeah, so this process is a simple process I have just shown you. You can also add multiple complex algorithm and complex shape and complex simulation. And you can I hope you understand how you can design your own SolidWorks file, and you can also use different design tools and design like material. And what you need is a final IGS file you can import here. I hope you have understanding, and most importantly how to control the robot like very precisely. I know there are different axes here, you can control multiple axes here, and these are very important when we are talking about precision, how you can precisely attach your gripper to your object. Okay, I wish you a wonderful day. Have a great day. Bye.